Hi, I'm Mike Cruz and I'm going to be discussing the triangle forces feature of the most recent release of our Newton software. And I'm also going to be delving just a tad bit into the new Where tab of the Surface and Material visualization window. So the triangle forces feature, we intend this to be used primarily for feed and receiving belts. And we can use those to look at the parallel and perpendicular forces that are applied to those belts. So a few things to note. This feature only works for layers that have a surface velocity. So if you had a hood or a chute backplate with no velocity, those forces won't be recorded for it. In future versions of Newton, we're going to change this so that the user can simply input a vector and say this vector is the parallel direction for reference for these forces. So secondly, as with the where data, we intend for these forces to be used primarily to compare different designs within Newton. So we can look at the belt forces with design A and say, well, is there a stronger positive or negative transverse force on the belt with this design versus that design, and what seems to be the best design to use. So in order to record these forces, we have to do a few things. So if we go to the general simulation variables, we have to make sure that we set the save triangle force and work data to yes in order to record those forces. Secondly, we're going to want to make sure that the belt is meshed up into relatively fine triangles so that we can resolve all the detail of those forces. And third, we got to make sure that the normal vectors for that belt are all pointing in the right direction. So let me import this file and I'll show you what I'm talking about. So if we right click in the screen, we can turn on triangle normal vectors. And then we look at our receiving belt. We want to make sure that all those normal vectors are pointing upward and inward toward the center of gravity of our belt. So when you import a geometry in Newton, Newton automatically looks at each layer separately and finds the center of gravity of that layer and tries to point all the normal vectors toward that center of gravity. So if you draw the belt on its own layer, then when you import the belt into Newton, Newton should always calculate those normal vectors properly because the center of gravity will always be right in this region here. So now that we see that those normal vectors are pointing in the right direction, we're going to go ahead and mesh up that belt. We'll hit our equalize triangles button once, and then hit the divide triangles button a few times. And I want it a little bit smaller than that, so something like that. Now we turn on those normal vectors, and we can see that they're all still pointing in the right direction. We want to make sure our belt has a velocity. Wrong belt. This belt here. Got to give it a velocity in the negative x direction, so that'd be negative 2.5. Now we check those velocity vectors, and we can see there's a velocity there as well. So we're good to go. Now let's go back and look at that playback file. So, if we orient our receiving belt and look at it from a top view so that the positive direction of that belt velocity points toward the top of the screen, then a positive perpendicular force will be pointing to the right and a negative perpendicular force will be pointing to the left. So looking at this picture here, we can see there appears to be a net positive force on this layer. So the material is impacting the belt and trying to push the belt to the right. Now, with the parallel forces, a positive parallel force is going to point along the direction of the velocity. So a positive parallel force would act to push the belt along, and a negative parallel force would act against the direction of the velocity of the belt, so it would kind of hinder the belt. So you can see right in the loading zone here, we've got a lot of blue negative parallel forces, and that's because the belt is really working hard to accelerate that material in the belt direction. So when we generate our summary, if we leave our min and max scale set to 0, Newton will automatically calculate the minimum and maximum based on the maximum force on any single triangle. But that's usually not very helpful. We want to pick a meaningful scale, a fixed scale there, so we'll set that to 1. And we can see those forces. We've included a few filtering options as well. So you can use either a moving average filter or an exponential filter to look at those forces. If you set it to none, you can see that forces are a very quickly changing and transient quantity, so it's kind of tough to see what's going on with the belt here. We can see there's an abundance of positive force here, so we could assume that that means our belt's being pushed to the right, but it really helps if we use that exponential filter. We recommend using a value between 0.05 and 0.2. Values close to 0 will cause those observed forces to change much more slowly, and values close to 1 will make it change much more quickly. And of course we have the nodal versus triangular rendering as well. So triangular will simply color each triangle according to its own force, whereas nodal will distribute those forces between the adjacent triangles and create a smoother picture. We have the ability to show the total layer force and the max layer force in the rendering window as well. The max force is simply that max value on any single triangle, parallel or perpendicular. Now I want to take this time to mention that all of these features, we've revamped the work tab as well and kind of given it a similar format to the triangle forces. And a lot of the stuff that we talk about with the forces will apply to the work as well. So when you're generating the summary, you can go ahead and switch any of these features here in the window that you want without affecting the force data at all. And the same goes for generating a work summary. If we switch this to work, we can go ahead and switch back and forth between the different triangle wear types, and we can change our value to whatever we want. And it's not going to affect any of that data. But if you're in the middle of a summary, if you're in the middle of, say, a force summary, and you switch a layer to force while the summary is generating, the summary will stop and that data will be reset. And the same applies for work. You cannot switch a layer to work while the summary is being generated. Now with the work tab, there's one other thing to keep in mind. In order to generate the particle impact or particle abrasion, you have to make sure that particle coloring is set to work as well. So then when you generate this summary, Newton is recording the work both for this layer here and also for the particles. So you can switch freely back and forth if you want. Switch that to lumpy. You can switch back and forth between particle and triangle abrasion while that summary is being generated. And none of the data is affected. So these forces can also be included in the animation file. So when you save keyframes in the animation file, all of the data on this tab here, on this force tab, and all the data on the work tab is saved with each keyframe. The only rule that you have to follow with the animation is the same as with when we're generating the wear summaries, where when you get to a keyframe that has a layer colored to force, where the previous keyframe did not have that colored by force, it's going to reset the force data. And the same applies for the work. It would reset that work data. So these forces are also included in our plotting window. This was formerly called the results window or the output results window, but because primarily all we're doing with it is plotting, we've renamed it to the plotting window. So we can go ahead and set our layer here to receiving belt, and we can look at the tangential, parallel, and perpendicular force, and we'll go ahead and hit plot there. And you note that everything is being rendered in our rendering window here. And the way it's rendered is exactly how we set it in the SMV window. So while this summary is being generated, we can still switch around all these settings. We can change whatever we want. Obviously, we can't change something to force or work, but we can change any of these settings, these rendering settings around. It won't affect how the layer forces are applied here, because this is simply looking at that total layer force. It has nothing to do with the way it's rendered. And the same goes for that work tab. When we're generating the work summary, we can be changing any of the settings in here that we want, and it's not going to affect that summary. Now, with that in mind, we've covered the basics of plotting and viewing the triangle forces and the triangle wear. So I think that about covers it for this tutorial. If you have any questions, please feel free to email us at info@actek.com and we can give you a few pointers. So have a good day.